Hey everyone, thank you so much for joining today. It's great to see so many of you on the phone. Um, we have a really great topic today. Chris Burns is going to talk about bringing your own containers and algorithms to SageMaker. So it looks like this is a topic that's of interest to a lot of you, and we're happy to see that. I think you guys all know the drill at this point, but I'll do a quick intro of Chris Burns. He's a senior partner solution architect with an AI/ML specialty. And he used to work in industrial robotics, and now he helps you guys, all of our AWS partners across the AWS ML stack. Also on the call today, actually joining in just a minute, is going to be Chaitanya Hazare. And you also probably have heard from Chaitanya on previous calls. He's going to be answering some of your questions. So there's that right navigation pane of GoToWebinar. There's a chat function at the very bottom where I was kind of putting a little bit of info earlier. If you have questions during the meeting, you can pop those in there. You can send those to the entire audience. You can send them only to the organizers, which is Chris, Chaitanya, and myself. And we'll get those answered either live here on the call, or if we don't get through all of them, we'll send out an email afterward. Also, at the end of this webinar, you'll get an email with a link to the recording. You'll kind of have to re-register to see it, but in case you want to go back and kind of review any of the information, that'll be available as well. So without further ado, I'm going to toss it over to Chris Burns.
Thank you, Sue. Hopefully this slide is refreshing here. I'm not sure why I put this slide in here. You do such a good job introducing me. I don't need to introduce myself. But
I want to say, you got to get the visual solid.
So thank you again to everybody that's joining today. I know your days are very busy. I know this because I'm a partner solutions architect, and then I know what some of you partners are working on. So it's incredibly humbling to me that you take time out of your day to spend with us and listen to what we have to say. Also, these webinars are live for you partners. So I'm right here to answer questions for you on the spot. And as usual, you can follow up with emails anytime after this webinar ends. And today we are celebrating, this is 1 year of our partner deep dive webinars. We kicked it off a year ago this month with an image classifier. So let's dig in. The agenda for today is going to be a little bit different. If you've attended past webinars, we do a lot of Jupyter Notebooks. We do a lot of data science related tasks right here in the webinar for you to view. Today's going to be a little bit different. I'm going to go over the prerequisites that you need to know. And these prerequisites are not for this webinar. Anybody can sit in on this webinar and hopefully take away some good information from the content that we're going to present. The prerequisites are what you need to put this into practice once this webinar is over. We're going to touch on Docker. I shouldn't even say touch. We're going to get into Docker. Probably about a quarter of our time today is going to be spent on Docker. If you want to bring your own SageMaker container, you need to have an understanding of Docker. You don't need to be an expert. By no means, I'm not a Docker expert, but you need to understand how containers work, how a Docker file is assembled, and how to put that container together so that you're going to be more versatile when using SageMaker. We're going to talk about how SageMaker containers work. So just a little bit of context around that. SageMaker has a couple of rules that your containers need to follow, and we're going to dig into those rules and see how that works. Then we're going to do a live coding demo. Almost 100% live. I did do a little baking show where I spin up an endpoint at the end. An endpoint takes 6 to 7 minutes to spin up. I didn't want 6 to 7 minutes of awkward silence or me talking about unrelated content. So I've got the endpoint running already, and you're going to have to just trust me that the container that we build today is exactly the same as that endpoint that's running. And then finally, Q&A. Now the Q&A is at the end, but as usual, don't think you have to wait till the end to get your question in. Take advantage of that questions box, get those in so that myself and Chaitanya can take a look at those and get them answered in a timely fashion. Now, SageMaker, I don't want to assume that the audience has experience with SageMaker, but hopefully if you're here today, you have an idea of what it is. And what it is, it's a fully managed service that covers the entire machine learning workflow to label, prepare your data, choose an algorithm, train the model, tune and optimize it for deployment, make predictions, and then take actions on those predictions. That's a lot of stuff. I like to call it not just a tool, but I like to call it a tool chain. We have different names. Sometimes people call things platforms, sometimes they call them frameworks. I like to call SageMaker a tool chain. Now, this is not a SageMaker 101 webinar. I want to put your mind at ease right there. But if you want to take this webinar and you want to go put it into action afterwards, you have to understand some of the components of SageMaker. Now, I'm going to talk about SageMaker in a little bit different context. I want to talk about why I call it a tool chain. So we say that it provides every developer and data scientist with the ability to, I'm going to just pause right there, every developer and data scientist. Those are kind of like two sides of the pants if you think about it. When I think of data scientist, please don't take offense to this. This is not an exhaustive list, but I'm thinking statistical thinking, understanding of probabilities, digging into data architectures with data sets, visualizing data transformations. That's what I'm thinking about when I'm thinking data scientist. Now, when I'm thinking developer, I was a developer myself for nearly a decade. I'm thinking divergent conceptual thinking. I'm thinking computer science, memory management, performance engineering, user interfaces, user experience, and of course, DevOps. These are two different worlds, if you will. So how does SageMaker combine these two worlds into a single tool chain? Don't laugh at my graphics here, but I see SageMaker as a bridge. I call it a tool chain because it connects these two different worlds. It's possible, it's perfectly acceptable that you will use some parts of SageMaker daily and other parts rarely or never at all. So what point, I guess, am I trying to make here? The point is that even if you live and work entirely in one area of depth within SageMaker, you have the ability to step into the shoes of other roles to better understand the entire lifecycle of your solutions development. So I'm hoping today on the call, we have a great number of attendees. I'm hoping that you're not all DevOps professionals. I hope there's some data scientists mixed in there. I hope there's some high-level architects, some thought leaders in there to see how you can extend SageMaker beyond our built-in algorithms, beyond our options for building a container, and bring your own container into SageMaker. The second prerequisite, is Docker. Now, Docker is one of those words that it's a noun and it's a verb. Docker is obviously a company. It's a software package. But to Dockerize something is to package software into standardized units for development, for shipping, and for deployment. It came onto the scene, almost a decade ago, and it came on with, quickly it came on the scene. I had to make several attempts at moving to a container-oriented mindset because there is a learning curve. And like I said, I tried it once. I said, I don't really understand what's going on here. I left it alone. Tried it again, maybe even a third time, who knows? But eventually I got to the point where it clicked for me. I understood the benefits of using a container. I saw immediately the value in spending a little bit of time on that learning curve. And I've been reaping the rewards ever since to be able to help partners and help customers with container-based infrastructure. If you've ever heard the phrase microservices, containers enable microservices. SageMaker is taking advantage of containers to allow you the flexibility to bring different frameworks and different models and deploy them in a highly scalable, highly resilient manner. A couple of things I want you to know about Docker before we jump into it. I got these from Datadog. So Datadog gets full credit for these graphics. I do not. 25% of companies have adopted Docker. That was actually lower than I thought. But still 25% of companies is a lot of companies. And then the image on the right is really what I wanted to bring home to you. The average container lifetimes, if it's orchestrated, we'll get into orchestration in just a moment, half a day is the life cycle. That tells me that these companies are very, very, very agile. They're constantly updating. There's a concept in development called immutable. If something's immutable, it means you don't change it, you simply replace it with a new version. So that's telling me that these companies are really, really moving in a microservices direction, using these containers as they are meant to be, constantly updating, constantly scaling back and scaling down. So that half a day life cycle, the half day lifetime was an eye opener for me. Okay, so we're going to get into some Docker. Quick overview of Docker, and then I promise you that there is some live code. It's just going to have to be patient. But Docker overview, if you're familiar with Docker, I apologize for the retread. Obviously, we have lots of different levels of expertise in our webinars, so we got to start at a certain level and build up. Now, the Docker engine, written in Go, it has multiple components. What I want to point your attention to is the container D. That container D is an open source runtime. It's what allows AWS to run Docker containers right from Docker Hub or from our ECR, that's Elastic Container Repository. Container D is this open source runtime that speaks Docker. Orchestration, we're going to get into that in just a little bit more too. And Just like it sounds, it's used to describe the process of starting and stopping containers according to some pre-designed plan. We're not going to use orchestration today. I'm going to demonstrate, I'm not going to demonstrate what it is, but I want you to understand what it is. If you have heard of Kubernetes, Kubernetes is an orchestration framework. So if you have multiple containers running in some fashion, it's going to help you move the pieces around the chessboard, so to speak. Now, Docker build is a component of Docker that lets you build containers from a Docker file. There's multiple ways to build containers. There's something called Docker Compose. We're not going to dig into that today. Docker Compose is for assembling multi-container solutions. We're going to stick with just the Docker file. We're going to keep it Docker file. Excuse me. We're going to keep it simple, and I'm going to break down how that Docker file is built and the components that you need in there to build a SageMaker compliant container. Now, what this Docker engine does is it builds and it manages Docker images. I want to make sure I'm going to try to draw the distinction here between a Docker image and a Docker container, because we in the biz just call them containers. Now, a Docker image, if you have any experience with virtual machines, you might recall that there was like a gold standard virtual machine from which all other virtual machines would spin up from. Our EC2, Elastic Cloud Compute, those are technically compute instances, and each instance is in an instance of an image. So same thing with containers. We have an image that can spin up multiple containers of itself. And so when a Docker container is live, resident in memory and running, it's called a container. When it's not live and running, it's called an image. I wanted to just draw that distinction because I'm going to use these terms throughout the webinar today. All right, so I have a Docker file here. This slide is technically read right to left, so I apologize for that. But on the right is a snippet of a Docker file. I wanted to just pull out a couple of relevant pieces of information from this Docker file so that you can understand this. I'm going to hop around a little bit today. And it's not just my ADD. I'm trying to find the best way to expose you to a couple of concepts initially and then dig into the concept in more detail later, but in a manner that covers the entire container ethos as it applies to SageMaker. So this Docker file is just a text file. You see this first line from NVIDIA/CUDA10, that's what we call our base image. So I'm going to build my container based on that image. That image is supplied by NVIDIA. That's what that means where it says NVIDIA, that's the repository owner. So there's Ubuntu. If you go to Docker Hub, there are literally thousands and thousands of images that provide base images all the way up to purpose-built containers ready to go. Now, the next section here where I have a comment where I'm going to install utilities. This is standard aptitude, apt-get, and then apt-get install here. I'm going to install some wget, some Python 3, some pip, some nginx. These are the dependencies that my model is going to need to run in this container. And then finally, some dependencies I install with aptitude, some of them I install with pip. If you're not familiar with pip, I don't want to get into too many details here. It's a Python package management system. But here's where I'm installing gunicorn, requests, Flask, all the things that my wrapper code needs for my model. And then finally here, I'm going to copy the directory of my host, my EC2 host or your host on site, into the container, into the working directory. Now, if this doesn't make a lot of sense right now, rest assured we're going to get into this in a little bit more details in a little bit, and you're actually going to see this done live. I want to quickly throw some Docker commands at you. Six commands that I think are probably the most common commands. If you're going to build your own containers on SageMaker, you're going to need to know these commands. Docker pull. It just means that you're going to pull the base image or you're going to pull a pre-built container from a repo. That could be Docker Hub, that could be ECR, it could be some other repository that you might be using, but that's going to pull it down to your local instance so that you can modify, inspect, and run that container. Docker build, that's the command that we use when we have assembled our Docker file to turn that Docker file into a container ready to ship, ready to deploy, and ready to use in your production environment. Now, Docker images is actually a command that lists all of your images that are stored locally. You'll see me run that here in just a little bit. Docker PS lists all your running containers. Now remember, we drew that distinction between what an image is and a container is. I could have dozens and dozens of images on my local machine and actually no running containers because none of them are resident in the Docker engine. Docker RMI, Docker/RM, is one of my favorites. It's for deleting images in containers. Containers can can get out of hand pretty easily when you're experimenting and when you're using Docker files, especially if you're automating any of this process with CI/CD pipelines. So Docker RMI deletes images and Docker RM will delete containers. And then finally, we have Docker run. This is what's going to take an image, it's going to run it, it's going to put it in memory and run it in the Docker engine as a container. Now I'm going to pause here because I know I'm talking fast. I have a tendency to talk very fast. I'm going to go to the questions and make sure that there are no questions yet. There are no questions. So that tells me that we have a bunch of Docker experts and you guys are ready to go. So next section, I want to dig into some of the SageMaker container management aspects. So some of the rules you need to know when you're building containers. I know this is a busy slide. I apologize. A lot of information here, but I want you to know the EC2 instance relationship, the ratio in SageMaker is 1 container per instance. If you're familiar with ECS, we have a lot of different ways to pack containers onto a host. We have memory optimization. We have something called bin packing, where you can fit a lot of containers by volume onto a host to really maximize that CPU's utilization. Docker has many benefits. One of them is just the portability of code. That benefit is enough for SageMaker to use Docker at a foundational level like it does. So I want you to understand that when we're talking in SageMaker terms, a SageMaker training instance, a SageMaker hosting instance, 1 container, 1 instance. Now, you can spin up multiple instances, of course, when it comes to training and hosting, but just know that each instance that you spin up, each EC2 instance, each EC2 instance is going to hold 1 container. So that container gets the entire capacity of that machine to work with. Now, there's lots and lots of ways that you can build containers on SageMaker without getting your hands dirty with the Docker file. I want to go over those because there's chances are, I think the 80-20 rule is going to apply here. 80% of your use cases can be taken care of by these few scenarios. There's our built-in algorithms, which hopefully if you've heard of SageMaker, you know we have built-in algorithms. I believe it's up to 15 now. Please don't quote me on that. I could be mistaken. But when you run a built-in algorithm, you're running a container that we build and maintain. And that container holds everything you need for training purposes as well as hosting purposes. So when you hear built-in algorithm, think that's a built-in container. Now we've recently launched pre-built container images that don't have models, they don't contain models, but they contain the frameworks. It's sometimes not a trivial task to Dockerize a framework. So we have containers for PyTorch, for TensorFlow, for Chainer, for MXNet, and they're ready for you to use to train your custom model if our built-in algorithms don't solve your business need. These pre-built containers are open source, so you can extend these. You are free to modify these in any way you see fit. Maybe you have a PyTorch instance where you need to do some custom data loading with a larger data set. You're free to extend these containers as you need. Now, we also have the pre-built containers plus marketplace models. If you were not aware, we have a machine learning marketplace for models that you can browse. You can pick one that suits your needs, give it a try. You can pair that with one of these pre-built containers or your own container, and that may satisfy your needs. Also, we have pre-built containers plus the Model Zoo. Model Zoo is unique to Gluon. If you're unfamiliar with Gluon, that's a framework that sits atop MXNet. I don't like to compare it to Keras, but I guess you could draw some similarities to Gluon on top of MXNet, like a Keras on top of MXNet or TensorFlow. But that comes with the Model Zoo. A lot of pre-built models already trained in there for you to use. And there was the just released PyTorch Hub. So PyTorch Hub holds a lot of models from the community built by individuals that can submit those. And you're free to just grab one of those models. You have to please check the licensing there. I want to make sure I cover my bases. Combine that with a pre-built container and host that in SageMaker. And now if all of these scenarios still don't cover what you need, you have 100% custom. You can go completely freestyle on this, provided you obey a couple of the SageMaker rules. So what I did for this webinar and for actually another use case was I took a YOLO framework. So I did not use a MXNet or a TensorFlow or PyTorch. I used it's called DarkNet. It's just a C++ YOLO model. And I trained that to detect the suit and rank of playing cards. And I wanted to host it on a SageMaker GPU instance. So I basically took the hardest possible scenario I could imagine and put a container together for this webinar. And it was also, in full disclosure, it was also for part of a workshop at Remars. So we're going to get into the anatomy of this container as it applies to SageMaker. So hopefully you got your mindset right now, and you're thinking about containers as this unit of code. It's abstracted from the underlying host. You don't need to worry about any of that. And at the center of this container is your model. Also, I do apologize. I'm approaching this as containers for hosting models that have already been trained. I'm going to tie it off towards the end of the webinar to show you the difference between training containers and deploying containers. You can actually use the same container for both purposes of training and model hosting, but I don't recommend that. I want you to start thinking in cloud terms. I want you to think planetary. So when you're talking about scalability, don't think, does this work in a test? Does it work under duress? Does it work with millions of connections, thousands of connections per second? So you want multiple containers, one for training, one for hosting, so that we go back to that immutable concept. You don't want to update just the training aspect and then you have containers out of sync because you didn't update your model containers. If you separate those containers and keep containers dedicated for training, dedicated for hosting, you're going to find scalability is easier, your change management is easier, your CI/CD pipelines are going to make more sense. So sorry for that divergence there, but back to the container. The model is at the heart of our container. And for this purpose, for today's demo, we're going to talk about the YOLO model that I've built. And remember that YOLO model was trained to detect the suit and rank of playing cards. In order for that model to communicate with the network outside of the container, we have to wrap that in some kind of code. Because remember, our model is technically just some weights and biases. So we use internally here with the SageMaker built-ins, we use Flask and G Unicorn. Now, let's clear the air about G Unicorn. It's called Green Unicorn. And for years, I didn't know how to pronounce it. I literally had to ask before this webinar, what are we calling this G Unicorn? So you can call it Green Unicorn, you can call it G Unicorn, or you can call it Gunicorn, but you can't call it Goonicorn, which is of course what I had chose. Anyways, that's your wrapper around the model, and that's going to give you network connectivity outside of the container to your model. Next layer is Nginx. So back to Flask for a moment. Flask is a very, very popular framework in Python. It is not meant for production. It even says it when you start the Flask server. It says, please, please, please don't use this in production. So it's great for returning inferences, but it's not great for managing connections. That's why we wrap Nginx around Flask and G Unicorn. Now, if you're not familiar with Nginx, I have suspicions that it secretly powers the entire internet because it is everywhere. It's a very fast, a very lightweight, a very small footprint web server that can handle thousands and thousands of connections without fail. Very, very popular, and also available as a base image and free to use. So what I'm trying to do here is I'm trying to kind of peel the onion, so to speak, but in reverse fashion. We started with our model on the container. We wrap it with some Python code to interact with Nginx. Nginx interacts with the outside network. All right, I'm moving pretty quickly here. Still no questions, so I'm going to assume everybody is, well, actually I lied to you. We're not going to do the live demo just yet. A couple more things. And again, I'm going back to the hopping around a little bit. What we have here is an example of a Docker run command. And as you can see, it's pretty verbose, a lot of pieces to it. Don't think you have to memorize this on the spot, but I want to pick this apart just for a minute to show you the different components. So Docker run, hopefully you recalled that from the 6 major commands that you really need to know. Now this next one is a little bit, how do I want to call it? I don't want to call it an outlier, because if you're using GPUs for training purposes, then you're going to need to know this is here. I'm using it for hosting purposes. If you want to use the NVIDIA runtime, so if you want to use Docker containers with a GPU, you have to specify the runtime here as NVIDIA. Now, when these are being hosted in SageMaker, you're not going to have to write this command. I'm showing you this command because you're going to need this when you're building the container, when you're testing, when you're getting that built and debugged. -IT means interactive mode. It's very easy to spin up a container and not be able to access it. because maybe you don't have a web server running yet, or maybe you don't have your APIs written to access the code that you have on the container. So it just sort of runs there inaccessible. IT lets you, in interactive mode, you actually drop into a command line within the container. One of the tips I have for you, and I did it with the YOLO container, was I was able to start a container in IT mode. Then I did my apt gets. I did a lot of downloads and package management. And then from that point on, I got the container where I wanted it. And then I built my Docker file based on the steps I took while I was in interactive mode. Sometimes if you want to just build a container from the outside in, so to speak, and you're doing just a Docker file, in order to test that, you have to literally build the container each time. And when you're doing rapid iterations, that's not very practical because it's going to take 2 minutes, 3 minutes per iteration, and you want to move faster than that. So in the purple box here, I've named my container YOLO. Docker will name your container a clever 2-part name that consists of like one noun and one adjective. Some humor to be found there actually when you're looking at your Docker containers. The -P, I'm porting port 5000 from the Docker image to my host. So if my Flask server runs by default on port 5000, I need to be able to port map that port to my host. Now, image there in brackets, that's the image that you're using to spin up. So in our case, I believe I call it YOLO v3 or YOLO something like that. And then serve is your entry point. I don't want to touch on entry points just yet. We're going to get to that in a couple of minutes. But some important aspects to understand about the entry point to your container. Serve and train are the entry points that SageMaker requires. If you want to deploy an endpoint in SageMaker with your own model, your entry point, or your command has to be serve. And you'll see that serve is actually a Python file that spins up our GUnicorn and our Flask servers and gets everything rolling for us. Same purposes with train. Just a couple more slides here to tie this off. What you have here on the right now is my directory, my source code directory. YOLO is the root directory. A Docker file is alongside that. And then within the YOLO directory, I have some files here. This .so file, when you compile a library in Linux, it ends in .so. So if you're from the Windows world, this would be like a .lll. This is literally my model's library. And these files that begin with ACEs are configuration files and parameter files. So we can pretty much disregard those for today's purposes. I'm not going to get into how I trained and compiled this particular model. I just want you to show how I can take this model and wrap it into a container. This YOLO v3 app.py, this is my wrapper. This is holding the Flask code, and this creates the invocation and the ping methods that we're going to see in a little bit. So just like serve and train are required, and it's required nomenclature for SageMaker, you have to have a ping method and an invocations method. The ping method is what allows SageMaker to know that your container is still available, still responding to commands, and the invocations is your actual inference command. Now, you're more than welcome to put additional methods in there as app routes, but you have to have the ping and the invocations. This WSGI, that stands for Web Server Gateway Interface. So maybe not named very well in this instance. I apologize for that, but this file serves as a wrapper for GUnicorn. That's all it does. There's like literally one line of code in there that lets you configure this on the fly without having to change your YOLO v3 app.py or whatever your wrapper file is called. And then finally, we have our nginx.config file. Pretty static. You can just grab one of these out of some of the examples that we have in GitHub for bring your own container, and you can specify the number of threads that you'd like this web server to run on, because even though we have one container to one EC2 host, we can still spin up multiple threads of our model within that host. And you're going to have to play with that to see what memory is going to allow. All right, this is very important. And all joking aside, I wasted several hours, probably more than several hours, on this permissions issue. So what you have here is you have a view of the host, the EC2 host that this source code was on. And I want to draw your attention to the serves permissions. If you're unfamiliar with Linux permissions, I've broken it down here in the bottom left-hand corner. So the owner of that file, read, write, and execute permissions are determined by R, W, and X in positions 2, 3, and 4 of the permissions grid here. Now group is 5, 6, and 7, and then of course other is the final 3. So here's the point I'm trying to make. SageMaker, remember, SageMaker runs as a role. I have a very bad habit when I'm working on Linux to just do a sudo chmod plus x and then the file name, because I need that to be executable, and that's executable to the owner. So what I did was I did this very same thing here with my serve file, and when I tried to run it in SageMaker, I kept getting an error that serve cannot be found. And this is one of those errors where the error verbiage is not actually reflective of what the underlying cause was. The problem was it was a permissions issue. So you want to run sudo chmod u plus x file name, and that's going to give access to the group, and that's what you need for SageMaker to be able to access serve. So it's just a very, very tiny point I wanted to make, but incredibly important. Okay, now before I dive into the live demo, I'm going to pause here for 1 second and see if anybody has any questions. No questions. So if you bear with me for one moment, we are going to go to an EC2 host. Now I got black on black here. Sue, could you please verify that you can see the screen okay?
Yeah, I don't see it very well. Yeah, it's black on black.
Okay, so hopefully
maybe you can see your code, but I mean it's not great. Maybe maximize it. There you go. I don't know.
All right, so the first thing I'm going to do is I have a GitHub repo that I'm going to grab the code from. And it is called YOLO Docker. All right, and so hopefully we can see this okay. I'm not seeing any comments. And hopefully this looks familiar. This looks familiar because this is what we just saw in some of the slides where I laid out the file layout. And now, again, I'm going to draw your attention to the fact here that we have the Docker file is a peer to my root directory of my code. Because what we're going to do now is we're going to do Docker, if I could type, build -t, T means tag. We're going to tag this, so we're going to call it YOLO, we'll just call it YOLO v4 because I don't have any of those yet. And then I'm going to put a little period here because that means the Docker file is in the same directory as the command that I'm running. And now, forewarning here, this might not make a lot, you might not see a lot here. Oh, what's this? Looks like I already have it built. Yes, I do. So I'm going to delete some of these because I do want you to see the process by which dash force. I want you to see the image get built at least a little bit. Granted, the screen refresh might be a little bit fast, so I've begun with my base image here. I could even delete this too. And if you see here, what I'm doing is Docker RMI. I'm removing. I'm going to force this to be removed because I have containers on this host also that use this image. And so Docker is trying to tell me, hey, you still have containers here that use this. Don't delete it. And then you just need to type in the first few characters of the image ID. Now, with our images command, we should be completely empty. All right. So we're going to go back to the build command. And now what's happening is it's downloaded the layers, the images that I needed from Docker Hub, so the CUDA. I know this is hard to read. I'm going to try to narrate best I can. And what it's doing now is it's already moved into the Docker file into the apt.get and install portion of my Docker file, and it's installing all my dependencies. Now we see here we're running, if you can see that, don't worry about it, but we're going to pip install all my Python libraries. And now what it's doing is it's downloading a couple of files. Because I didn't use a framework and I was using GitHub, my weights file is 250 meg, a pretty beefy weights file for this YOLO framework. It doesn't fit into GitHub very neatly because you have a maximum file size. So I stuck that in S3, and I simply put a command in my Docker file to wget my weights file and add it to the container once it's been built. So that's what we're seeing right now. And then the next file that we're going to see is something very, very similar. Again, because I didn't use a pre-built framework, and this really speaks to the advantages of using an MXNet or a TensorFlow or a PyTorch, I had to actually move some dependencies, some OpenCV dependencies and some C++ dependencies to the container from the host. And the way I did that was similar to the weights file, I found all my dependencies with the LDD command. I zipped them all up into just a zip file, stashed it on S3, and then when I'm building my Docker container here, it goes and grabs that zip file, brings it down, and unzips them. So very, very, very flexible. A lot of if you have any experience with some of the bare metal provisioning tools that are very common, lots of ability here to configure your container on the fly. This is essentially infrastructure as code, if you want to use that buzzword. And apparently it knows that I'm on a live webinar and it's running a little bit slow for me today, so I apologize for that. Usually this runs much faster than this. But this is a great time to get your questions in if you have any questions. How about jokes? Anybody got any good jokes?
I know, right? Nobody's got any questions? Come on.
I have a joke. So what do you call a robot that takes the longest route? R2 detour.
You're a dork. That's good.
All right, the pain is almost over. We're at 91% here. I apologize. I did test this beforehand, and I thought that it would go a little bit faster than this, but at 99% here. Okay, so now what it's done is it's taken my library dependencies, downloaded them as a zip file, and now it's writing those to the container. And this is the last step. I've called that folder delete me for obvious reasons. Once it's done, I want to delete that folder. Okay, so we have our image. Now, this image exists only on my EC2 host here. It is not yet accessible to SageMaker. In order to make it accessible to SageMaker, I have to move it to ECR. That's our Elastic Container Repository. A couple of commands here that I'll try to type without butchering. Or better yet, I'm gonna copy and paste. I'm gonna cheat. So I need to make a repo for this container, and I'm going to call it YOLO v4 to be consistent. So this command here, I'm using the AWS CLI. You see there, AWS, I'm calling out the service, which is ECR. Create repository is the command, and I'm providing a repository name of YOLO v4. This JSON snippet is telling me that I have indeed created that repository. Now what I need to do is I need to log in to ECR on behalf of Docker. So a little bit more information there. This command, AWS CLI, of course, ECR is the service again. I want to get the login command so that Docker can log in on behalf of me to my ECR repo and upload my image. And so I get this very, very, very long command back, and really all you have to do is copy and paste this. What I should have done was just pipe this directly to the command line and ran directly instead of cut and paste. But all right, so I've run that command, and you see there, login succeeded. Now I can upload my images via Docker to my ECR repo. In order to do that, we're going to first tag it. To tag in Docker means to name. This was a test. We're going to tag our YOLO v4 image Now, a tag in Docker, like I said, it means to name, but it also, you specify the repo within the tag. So here I have my account number, DKR means Docker, .ecr means the service, and then we have US East 1, Amazon, AWS.com. You can't access that even though you have my account number, so don't try. And then we have, of course, our image, and I have the latest. So this is going to tag that image. Now the last step is to push the image from my EC2 host into my ECR repo. And again, I want to make sure that I have this correct. YOLO 4. Oh, and be mindful here that I've tagged it incorrectly. Well, not incorrectly, but inconsistently. I was calling this YOLO V4, and then my tag is YOLO 4. So matter of fact, let's retag. Let's retag. It's very easy. You can tag as many times as you want. And now we'll run that push command. I am copying and pasting these commands to save you the anguish of watching me type. Everything here looks good. YOLO V4 latest. And as you see there, it's pushing the layers. You see each one of those statements that's pushing, that's the same layers that Docker used to build our container. It began with a base image. And then every time I type run in that Docker file, it's another layer. So you want to be mindful. You want to try to use the double ampersand and concatenate as many commands as you want, or as you can, when you're creating a container, because if you just willy-nilly use these run commands in your Docker file, you're going to get really, really, really large images. And also, I forgot to tell you, I can't believe I forgot to tell you, if you do go with that method where you do a Docker run-it interactive, there's an ability to just Docker commit, and it just takes the container that you've modified and it creates an image from that container. I don't recommend that. For this particular container that we're seeing here today, it's a very large container at 3.5 gig. When I built this container and I was debugging and I had used the interactive mode and I used Docker commit to push this container, it was 25 gig. 25 gig. So it basically, I recreated a virtual machine is what I did there. So while Docker run-it is great for troubleshooting and debugging and building, I do not recommend Docker commit when it comes to SageMaker training or hosting instances. Try to use that Docker file, use what you've learned from the interactive session and build a Docker file to build as small as image as possible. Because even once this was all said and done, the NVIDIA drivers, all the CUDA libraries, because I used YOLO and it required OpenCV, this was still what I call a fairly heavy container at 3.5 gig. You have containers that are incredibly small. There's an Alpine. It's called Alpine, is for Python. And it clocks in somewhere around 60 meg or something like that. Incredibly small. There's no reason that you can't use that as a base and begin to build your containers. Okay, the push is complete. So we're going to visit my ECR repo. And here we have a YOLO V4, freshly uploaded. So at this point, I'm going to recap what we've done here. We've taken our source code that we worked really, really hard to write and perfect. Then we've built a Docker file around that to build a container. And we did this on an EC2 host. You don't have to use an EC2 host, but I recommend it. The deep learning AMI is going to make your life much easier. The DL AMI is your friend. I'll repeat that several times probably today. I built the container on the deep learning AMI EC2 host, and then I pushed it to my repo here. So that's where we're at. So now we're going to go to SageMaker because we want to run inferences. We want to get this deployed as an endpoint and run some inferences against it. Now, again, I'm going to do a little bit of almost reverse engineering here. I'm going to begin by creating a model. Even though our container is sitting neatly in ECR, it's not a model yet. SageMaker doesn't recognize that as an inference point. It's just a simple container, and it can do anything I want it to do. So I need to create the context of a model within SageMaker here. This is all pretty intuitive. We're going to call it YOLO V4. This is important. The role that you run this endpoint as. I got a little bit lazy with this model, and instead of passing binary image data to the inference point, I pass an S3 URL, and then my model goes to S3, grabs the image, runs inference against it, and brings it back down. Because I do that, I need to be mindful that my SageMaker role, my IAM role, has access to S3. Because if it doesn't have access to S3, when it gets to that code, it's going to do something, it's going to be unpredictable. But you can rest assured it's not going to be what you want. Container input options. I'm going to go over this briefly. We're going to provide model artifacts and inference image location. So what I should have done was I should have went back, I should have copied this. I'm going to copy my URL for my model. Sorry, for my container. Put that here. Append latest. But I'm sorry, back up to this container input options. You see here references to, if you think back to when I talked about the different ways you can take a container that's pre-built and take a model that's pre-trained, combine those and host them in SageMaker, here's where some of those options would be selected. You can pull models from the marketplace, and SageMaker needs to know this because it's going to assemble this container for you on the fly. It's going to pull from an ECR repo somewhere. It's going to pull a model from somewhere. It's going to put it together for you. It's going to wrap the API code around it and then deploy that to a SageMaker endpoint where it's exposed for consumption. I don't need to specify my model artifacts because my model is built into my container. But if you've used SageMaker before and you've used training, you know that once training is complete, it deposits a model.tar.gz file somewhere in S3. So if you were building your own container and using a model that you've trained in SageMaker previously, this is where you would supply the path to your model in S3. And if you have some DNS needs, provide them there. I don't need any environment variables. This is very important. If you're doing this via the API, I believe it's a different default. But of course, at AWS, we try to make everything as secure as absolutely possible out of the box. So this container, if I left this checked, enable network isolation, my model container would not be able to leave the Docker container network. So that means I cannot call S3. I cannot call other AWS services. So I'm going to uncheck this because I want my container to be able to go out to S3. And I don't need a VPC for this demonstration. I'm going to create the model. So the model's done. Now SageMaker has the context, it has the concept of a model based on my container. So we're going to take this model and we're going to create an endpoint configuration. An endpoint configuration, if you've ever done auto scaling on AWS, it's a config file that lives forever. You can always reuse the config file. But an endpoint config is different than an endpoint. Excuse me, I need to take a quick sip. Okay, so I have my model and I want to create an endpoint from the model. We're going to call it YOLO v4 endpoint. Now here's the configuration I just talked about. I don't want to use an existing one, I want to create a new one. We'll call it YOLO v4 endpoint config. A little verbose, but easy to recognize. I don't need any encryption, but of course you have lots of encryption options here with KMS. So it comes to this default setting here for my instance type. I have the variant name and the instance type. Now, because I trained this specifically to Volta, Volta is a type of NVIDIA GPU architecture. If you recall, way back, my library was actually called libyolo_volta. I can't run inference on an M4 because it doesn't have the NVIDIA drivers that I need. So I'm going to edit this and I'm going to go to a P3. P3 is the Volta architecture and the variant type, I'm sorry, the variant name, I'm going to call it production. This lets you do A/B testing, deploying multiple endpoints and then directing traffic to different endpoints based on your instance weight. Everything looks good here. I'm going to create my endpoint configuration. That's done. Also, if you see this little spinning wheel here, the training job, I did not train this model in SageMaker. I trained it elsewhere. So this particular snippet of code is trying to find the training job that was used for this model, and because it can't find it, it's just sitting there thinking. So we are done with the endpoint configuration. We're going to now create an endpoint. So the endpoint is created. Actually, it's in creating status. Now this takes anywhere from 6 to 7 minutes. Sometimes I've seen it take 1 or 2 minutes less, and sometimes I've seen it take a little bit longer. I'm not going to make you wait there. I'm not going to make you wait through that. Let me actually get a time check here. We're doing really good on time. So what I've done here is before this webinar started, I did the exact same process that you just watched me do, and I have an endpoint that's waiting for us that we can call. We can send an inference to. So what we're going to send to it is this image. Now, hopefully you can see this image as it is. This is not, it's not your screen. This is actually grainy. I found that training the model, I used very, very high res images for training. And then I quickly discovered that in the real world, that was too high quality of training data. So I had to actually back off my training data, but this is the quality of the image. I don't know what the Laplacian metric would be on this. Probably would be well below 1 in terms of blurriness. But this is the picture that we're going to send to our endpoint. And to do that, I'm not going to jump into a Jupyter notebook. That's a little bit of an overkill. What I'm going to do is I'm going to go back to my EC2 host, and I'm going to just run a simple curl command. So 1 second, I'm going to paste this in here. I'm going to modify this just slightly. And we called that yellow v4 endpoint, I believe. So very quickly about this command, there's a pip library, a Python library that you can pip install called AWS curl. And what it does is this particular EC2 host that I'm running on, I did not use a role. I recommend you use roles when you use your EC2 instances, but instead I'm using the AWS CLI here. And so I need to pass my credentials to this API call to this endpoint here. And so what I'm doing here is I'm using AWS curl, I'm calling SageMaker in the US East one, and I want to post this JSON snippet. So you see here t1.jpg. That's the name of my image that's on an S3 directory, and that's the image that I want to run inference against. And hopefully if I type this correctly, I did not type it correctly. So let's see what I did. Oh, that endpoint is not in service. And I needed to go back to my old endpoint. So what I did was I typed an endpoint that is not yet running. So what we want to call is just YOLO endpoint. Live demos. YOLO endpoint. There we go. So I got my inference code back. So I'm going to just explain this to you very, very briefly. You can do a lot of things with object detection. Some people like to return the image with bounding boxes drawn. Because I was going for raw speed with this particular inference, I only wanted it to return the bounding box coordinates, and then I have a lambda function that at the edge draws the bounding box on the original image. But if I open this again, and I do apologize if this is hard to see, my inference code took 0.98. I'm sorry, that's my confidence. The inference code took 0.16 milliseconds. And it sees an 8 of spades with a confidence of 98%. It sees a second 8 of spades with a confidence of 97%. That corresponds to the first instance of 8 in spades in here. And then it also hopefully sees a jack of spades. So here we are, a JS. JS means jack of spades with confidence of 99%. And again, I have a separate process that draws the bounding box that I could have tied in there. But let me return to the PowerPoint because this concludes the live demo. Oh, didn't need to do that. So time for some Q&A. Now hopefully this made sense to you. Hopefully this gave you a little bit of insight into how to bring your own container into SageMaker. It was the time allotted for this was probably not enough to go over training and deployment. But if you think back to this demo, remember there's a recording of this. So if you want to come back and play this again, for training purposes, you simply create a Python file called train rather than serve. And when SageMaker tries to train, it's going to run the code in that entry point. Whatever you have in that train file is going to. So you know what? I have a couple moments here. Let me. I got PyCharms open. I can show you this serve file. Actually, more important, let me back up and show you the wrapper. This is my YOLO v3 app. And so if you recall, I talked about the methods that you have to have. Here's my ping. Sorry if I'm moving this around too fast. Mandatory method there. You have to have that. You see I've decorated that so Flask can recognize that as a route. And so when /ping is called at my URL, this is the method that's run. And really what it's doing is I have embedded an image file with the source code, and it runs an inference against that image and returns just a simple message to SageMaker saying, yes, I'm here, yes, I'm alive, yes, I'm responsive. That runs literally every second when SageMaker runs or hosts your model. And then the second method that you absolutely have to have here is invocations. This is a post method called when you want to run inference. And I don't need to dig into the code here, but really what it is just interpreting a JSON payload to find out where on S3 the image is that I want to run inference against, and then it sends it off to my detect method, which calls my YOLO library and returns an inference as a Flask response. So that's also important here. You can't just return text. You need to make sure that you return a proper HTTP response. You need to make sure that you use status codes properly. It's going to help you later on with your debugging. So you see here, if an error occurs, I've set my status to 500 to let me know that there's an internal server error, and I need to go to my CloudWatch logs and see what's going on. All right, so we've got about 10 minutes left here. I want to make sure I get off over here to my questions.
Hey Chris, I have a question.
Go ahead. Hold on a
So,
second. It looks like we got somebody here named Chris Skrinak asking who let Chris Skrinak in.
I know. I tried to block him.
Sorry, Nathan. Go ahead.
okay. With abundance of other object detections, like how did you zero in on YOLO? And what was the need for you to bring your own container to SageMaker? Why didn't you use inbuilt algorithms?
Okay, so I wanted to use YOLO because I had a scenario where I needed object detection. Let me talk very briefly about the difference between image classification and object detection. Image classification, if you think to the ImageNet data set, it's pulled from a lexicon of almost all the words in the English language, and the ImageNet is all the nouns: boats, planes, animals, you name it. All the nouns are there. And image classification is going to tell me this is a boat, and I'm this much confident that it's a boat. 98% confident it's a boat. Object detection works on a smaller scale. So if you have a computer vision problem and you need detail, you need finite recognition of details rather than simple classification, you want to think object detection, because it's going to find an object within a larger image and not just say boat. It's going to say, here's what I found. I found an 8 of spades, and this is the exact bounding box of the coordinates that I found the 8 of spades. This is going to allow you then to expand into segmentation. You're going to find a number of instances of the 8 of spades in the file. What we did with the Remars demo is we tied this to some pose estimation with the blackjack dealer, and then we actually sent the inference results to a RL agent to tell us whether we should hit or stay in blackjack. So I needed to use a model that had object detection. We tried the single shot on SageMaker, and I wanted to try multiple threads. The gentleman I was working with on this project, he tried SSD, I tried YOLO, and we just simply said, whoever gets done first with the best results, that's what we're going to use. So SageMaker does have an object detection SSD plus, I think it uses ResNet or something like that. But also, if you recall, I knew I had this webinar coming up. So I wanted to create an instance that might seem a little bit strange, because it caused me a lot of extra work, but I wanted to create a container to represent a scenario where you simply could not use one of the SageMaker built-ins. So hopefully that answered the question. Was there two parts to that question? I went off on a little bit of a tangent there.
Yes. So the second part was, I get it, like your needs were not satisfied by internal SageMaker algorithms, but are there any other scenarios in which someone would be bringing their own containers to, bring their own frameworks to SageMaker?
Absolutely. If you think about the early days of SageMaker, we did not yet have scikit-learn, sklearn. We didn't have support for that out of the box. And so if you wanted to run that, which is a wildly popular framework, you had to bring your own container. We have new frameworks popping up continually. And while we're going to do our best to provide first-class containers to support those frameworks, maybe you want to use a framework that you're really familiar with. Maybe you want to do some R. Another wildly popular, I don't want to call it a framework, but it's a language. We don't provide R out of the box. I don't believe. I could be mistaken there. We add containers all the time. So anytime you want to run a framework, or you want to do some code on the fly that we don't support out of the box, you want to look to bring your own container. Because remember, the 80-20 rule is in effect here. We're trying to cover 80% of the use cases, but there's going to be that 20% that we simply just can't cover, because SageMaker is a managed service. We have to be mindful of version maintenance, making sure that everything is patched properly, keeping up with the releases from the framework vendors. So obviously it's a song and dance that goes along with keeping all these containers maintained.
Thank you. And one final question, please. What was your motivation behind using deep learning AMI? And is there a reason why we did not use Jupyter Notebooks for demoing this setup?
Okay, so Jupyter Notebooks, this is a trick question, isn't it, Chaitanya? Jupyter Notebooks are a fantastic tool when you're working in a group, when you have to take a data set and really dig into that for feature engineering purposes, for data cleaning purposes. But my data was already trained. I was already trained. I didn't need to manually get into a Jupyter Notebook. And everything I showed you here today, all the Docker commands, the Docker file creation, this is all automatable. So this is actually another question here. Could I have run these commands from a Windows or Mac shell? Absolutely. Docker is supported on Windows. Docker is supported on Mac. Is supported on just about every major OS that there is. And also Docker is a tool for infrastructure as code. So these Docker files can be created automatically, or I'm sorry, in an automated manner. You want to think about these in your CI/CD pipeline, so that when I check in my code, it simply kicks off the container build process and then pushes that container out to SageMaker, because everything I did in the console on SageMaker, when it came to creating a model context, to creating an endpoint, that's all also available via API. I found that on webinars such as this, if I just did that via code, it might be harder to follow along. So I use the UI for those purposes. But I use the DLAMI because I was using containers with GPUs. So if you recall, I said you don't have to be a Docker expert in order to use SageMaker, bring your own containers. And I also said I am not a Docker expert. So I'm going to revisit that comment. I am not a Docker expert. And NVIDIA has created some what I'm going to call magic code. It's magic code, because I don't know if anybody caught it, but I was using a base image of CUDA 10.1 in my Docker container. And when I deployed that last month, we did not yet support CUDA 10.1 in SageMaker, but the NVIDIA runtime translated that for me and allowed me to run that container with that particular platform, with that particular CUDA version on SageMaker, even though SageMaker's Docker engine did not yet support a 10.1. So that's why I use the DLAMI. DLAMIs already have Docker on there for you. It already has the NVIDIA framework for you. It has all the libraries that you would need to build out and debug and test your container. And that's why I said, I paraphrase that as the DLAMI is your friend.
Thank you so much. One final question, and then I'll keep quiet. What is CUDA, please, and why would?
I'm sorry, you're breaking up there. I heard what is, and then I didn't hear anything else.
I heard, what is CODA?
Oh, CUDA. So CUDA is, I forget what the acronym stands for, but that is NVIDIA's GPU code. CUDA is libraries to allow you to write code against a GPU rather than a CPU. And so that's a framework that you're going to find very, very commonplace if you're dealing with GPUs in NVIDIA.
Thank you, Chris.
Absolutely, absolutely. So a couple other questions here. I hope all the files used in the demo will be available after the talk. Yes and no. Yes, they are. There's no. I forgot to post a link, but if you go to GitHub and you search for a fellow named Christopher A. Burns, you're going to see lots and lots of repos. If you go to YOLO-Docker, that's all right there for you to play with. So nothing, no secret sauce in there. All the files that you saw here today. And if you have a need to deploy a model that detects playing cards rank and suit, it's all right there waiting for you. Let me see here. I'm going to make sure I go through these last few. I don't want to leave anybody off. But I seem to always finish early, and I feel like I should be spending this time. Just to reconfirm. Yes, so just to reconfirm, the container can be set to load the model from S3 and does not need the model baked in. That's absolutely correct. If you go back, if you think back to where I use the UI to identify the image that I want to use and where I want to identify the model, there are two separate text boxes there where I can specify, here's my container, all my supporting code, all my wrapper code, and here's my model out on S3. The S3 link was optional. So the container is not optional, but the S3 link is optional. And if there's no container, I'm sorry, if there's no image, if there's no model path on S3 provided, it just assumes, okay, all the inference code that's required is going to be on the container, so I don't need to worry about moving that model to the container and wrapping that in the API calls.
Hey, Chris, I've got a couple questions, and it looks like Chaitanya is not able to see the questions, so I've got one here. Just to reconfirm, the container can be set up to load the model from S3 and does not need the model baked in.
That is correct.
Correct? Okay, good. And Chris Greenhack is messing around. He asked if you are available for bar bat mitzvahs. And then he asked, does SageMaker support Andrew Ng's favorite framework? Free dinner is available if you answer that one.
Yeah, I see. This is why I asked who let him on. Bonus question for anybody in the audience still listening. Andrew Ng recently gave a talk, and he talked about one of his favorite frameworks, and the icon was like a P and a P, just two Ps. Anybody knows what that is? Please ping the group. Does Chaitanya know?
Well, I'm going to say Pied Piper, but
Pied Piper.
Yeah.
Yeah, you're mixing the streams here. I think that's a Silicon Valley term, Pied Piper, but I could be wrong. So here is if you're still out there, here is the link. To that code with a Docker file. So great example there of what a Docker file looks like. Bad example of coding practices. So remember, that was all done before this webinar, and hopefully you focused on just the container portion of the webinar and not my poor coding practices.
Hey, Chris, can you, if you can send me a couple of these links, someone's asking if all this material will be available after the webinar, and I'd be happy to include any of these links in the follow-up email that goes out to everybody who registered and attended.
Will do. So
okay, cool.
You'll get the recording, you'll get this link, and that recording, of course, will have all the slideware. And so let me just take this last few seconds while you're still here before you drop off to let you know that you are our partners. We are here as partner solutions architects, so you are my customer. If you have questions, if you want to have a follow-up, I had a fantastic experience at Remars where somebody that actually watched one of my previous webinars said, hey, I watched your webinar and they gave me this idea. And it was very humbling, but also very rewarding to hear that. So if you have questions, let me know. Also, if you don't have questions, but you take something from this and you go on and use that later, send me some feedback. Let me know that you did something so that I can make a mental note that, hey, this worked. Also, if you have constructive criticism about how we deliver these webinars, always always willing to listen to that, because the more effective we make these webinars, the better prepared we make you. And so, Sue, that's all I have. If you want to close it out for me, I greatly appreciate your time. Again, I know you have a lot of options when it comes to webinars and spending your time wisely. And thanks again for listening to us today.
Yeah, to everybody who's still on the call, I think if we missed any questions, I'm going to dig through those files at the end of the webinar. I'll get Chris to answer them, and then we'll include those on the follow-up email, as well as the links to all the materials from today. So thanks again for your time. I think you will see a quick 5-question survey pop up after you close the window. So we would most appreciate your time in answering those 5 quick questions, all multiple choice. Thanks everybody, and have a great rest of your day.